Okay, hello, welcome to Approaches in Psychology. I'm going to take you through the basics of the biological approach, AO1. Okay, by the end of this, hopefully you have an understanding, basics of biological approach. You understand genotype and phenotype, okay, and what the differences are, just key terms, make sure, from exam practice that you can get those in and just show that you understand them. And you'll understand this idea of evolution and behaviour and how it differs in the real world or in the natural world as opposed to maybe how the humans treat it. Okay, all of this is AO1. Okay, so the first thing, for those of you that are A2 students, you'll understand that kind of assumptions, but if this is one of your first kind of look at approaches, you need to understand that for each approach you have to have an understanding of the assumptions. So they could ask the assumptions of, you want to know what these kind of key headline assumptions are. Okay, biological approach. Hopefully you know that this suggests that everything psychological is first biological. So if you're a biological psychologist, you believe that everything has a biological basis. Okay, to understand human behavior, we must look at the biological structures and processes in the body, such as genes, neurochemistry, and the nervous system. So everything that I'm doing now, everything that I am, has a biological kind of assumption, a key to, how I ended up, how I am, started with my genes, with my neurochemistry, with my nervous system, and not, okay, just to kind of give you some comparisons which you'll need to do, the behavioural side, which you may have done before this, which would say that everything, it comes from our environment, and actually from the moment we're kind of born or even in the womb, our environment is shaping who we're going to become. This is saying, no, this is simply when the genes, neurochemistry, nervous system, these things shape our behaviours. That's our assumptions. Got to get that right. Okay, the genetic basis of behaviour. Behaviour geneticists study whether behavioural characteristics such as intelligence, personality, mental disorders are inherited in the same way as physical characteristics. So if we, nobody, well actually you could say that, but generally your eye colour, your height, even in some ways your weight is characterised by your genetics, and we know this where there's different genes. You'll learn in A2, some of you already will have, that lead on to different things and more chances of getting mental disorders or being a certain type or being faster, slower, better at this, better at that. Lots of these things are definitely inherited, and we know this. But is intelligence inherited? Is personality inherited? Are these genetic, or are these things that are built up over our behaviour, our learning through our environment? And that's what we're looking at, whether the genetic basis of behaviour is there. So how do they do this? And there's a few words in here I need to make sure you understand. Twin studies are used to determine the likelihood that certain traits have a genetic basis by comparing concordance rates. Now, concordance rates is this one that you need to make sure before you leave this slide, whether you need to go away and search it. If I don't explain it brilliantly, you need to understand concordance rates. The amount of essays that I mark where people clearly haven't and they're just saying it and it doesn't make sense. So a concordance rate is how much, I'm going to explain it badly, how much the things are the same, are accurate. If we take twins and we're saying, and I'll come to that, monozygotic and dizygotic. If we're saying that monozygotic, i.e. they come from one egg, one egg, they share exactly the same genes, 100%. No one's doubting that. It's the same egg and the same sperm, exactly the same, and then that splits into half. So they are identical. So for the genetic, the biological approach to say, yes, it's 100% genetic, these eggs should have a concordance rate of 100%. In most things. If this one is super intelligent, then this one should be super intelligent. If this one gets a mental disorder, this one should get a mental disorder. That's concordance rate of 100%. Okay, so when concordance rates aren't 100%, we're not saying it's oh, that's it, we just get rid of the biological approach altogether, but we discuss that concordance rate. So you'll see lots of concordance rates like 35%, and you'll have to discuss whether you think 35% of these eggs, out of every twin that you know, and you may know twins, 35% of them share the exact same intelligence score, or maybe get the exact same mental disorders, or maybe you pick any personality, aggression, any personality trait. A score of 35% concordance rate would mean that out of 100 sets of twins, 35 of them you've got exactly the same score. So you'll have to discuss that idea of concordance rates, and you'll see it from monozygotic to dizygotic. And dizygotic is still twins, but it's two separate eggs, two separate sperms. So very, very similar, okay, but not identical. So if we have monozygotics with a higher concordance rate, let's say 35%, okay, and then we get some dizygotic twins and we measure them for the same things, intelligence, aggression, blah, 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 and their concordance rate is 12%, what does that actually mean? Can we now say that well, 35% is much higher than 12%, therefore there must be a biological explanation? That's what we'll look at. You'll never see a concordance rate at 100%, but you will see concordance rates of monozygotic versus dizygotic, and you'll need to be able to explain and explore the difference, whether you think the difference is big enough, what does that actually mean for proving or not proving the existence of biological explanations for things. Okay, hopefully that makes sense. Now I'm going to go back to the slide. If any of that didn't, look up some of the studies, search some of the words. There'll be lots of things online about concordance rates. Make sure that you understand what that kind of means. Okay. If identical monozygotic twins are found to have a higher concordance rate than non-identical for musical ability, schizophrenia, then this would suggest a genetic basis. Hopefully I just explained that. This is because monozygotic twins share 100% of each other's genes. So they try to, why they use twins is because they try to kind of control as much as possible. You can't choose twins and then just choose two random people for concordance rates because there's too much. They choose this idea of they sharing 100% of genes or a smaller amount of genes in dizygotic twins. Hopefully that makes sense. You will see a lot of studies around twins when you look at the biological approach. Okay, genotype and phenotype. Okay, you just need to understand the difference, be able to use them as key terms when explaining it. Okay, genotype is their actual genetic makeup, so that's your genes. It's really easy to remember. Okay, that is our actual genetic makeup. Okay, whereas phenotype is how these genes are expressed. So that idea that you as your gene makeup, you could be a million different things from that genetic makeup. Let's say, just to put it in sport, it's a really, really sporty person. Okay, and this genetic makeup is going to say that they're going to be fast, they're going to be, agile, they're going to, have all of the correct kind of genetic makeup around that could make them a fantastic sportsman. But their phenotype is the way that they express that. So that gene, that person, okay, could decide or could grow up in an environment without any sport. They could grow up in a country where sport's not seen as a good thing, and therefore that the genotype isn't expressed in the phenotype. So the example here of identical twins have 100% the same genotype, but if one does more exercise than the other and the other eats more fatty foods, then the other twin will be fatter than the other. So they could be, that's again my two 100% the same genotypes, but the phenotypes, how they're actually expressed, are going to be I don't want to say learn, are going to be changed by the way they behave. Okay, and if one gene doesn't do any exercise, or one human doesn't do any exercise, doesn't do anything like that, then obviously it doesn't matter how their genotype was, their genetic makeup, they're not going to be an amazing sportsman. Whereas this one may do something completely different, eat healthy foods, do all of that, and their phenotype is going to be different. Hopefully that makes sense. They're just key terms, you just need to be able to use them when you're writing about it. Again, nature versus nurture is one of the things that hopefully you're starting to see comes up in genotype, nature, phenotype, and nurture. Okay, evolution and behaviour. Just need to get your head around this. Okay, it is a biological part. Okay, evolution. Evolution of animals and plants is fact. Farmers select the best animals to use to sell the meat in supermarkets, for example. Now, so much of evolution is controlled by humans now, and I don't know if you know, but the cows that you eat, any of you eat a lot of beef, you do a short search on how they came about, and it's quite scary how much they've been kind of genetically modified by, like, getting, oh well, that animal's really fat and doesn't need much feeding to get that fat. Oh, that animal's really this. Oh, let's put them together and make the cows that we see now. Okay, are not cows that you would have seen 200 years ago. They've been kind of chosen and put in this unnatural selection. The same as any of you have friends with dogs or cats, Siamese cats, Siamese dogs, Japanese dogs, something like that. The ones which are really wrinkled faces, okay, that people like them. They're bred because people want them, but actually genetically they're completely flawed. I have a friend who has those. They snore, they can't breathe, they get breathing problems, they eventually, they have quite a short lifespan because of all of the problems they have with all of this skin and everything over them. So they've been chosen because humans, oh, that's pretty, I want a wrinkly dog. So it's unnatural. Whereas in nature, natural selection occurs naturally. Okay, nobody decides what is selected. It's those with the most advantageous genes, a better probability of survival and passing on the traits and genes. So in the wild, in nature, those dogs wouldn't survive in the slightest. Okay, they would never have come about because they have too many issues. They're too slow. They're too chunky. There's no reason for those dogs to have survived. Okay, next one's AO3. Hopefully, I didn't talk too much. Go and search anything if you didn't. There'll be lots of things online. Thanks. Bye.